Hi everyone. So now that we have learned about thread safety, how to ensure that there are no race conditions at all, so I'll be summarizing a lot of things now. So guys, there are broadly three ways through which you can ensure whether your code is thread safe or not. Okay. See, the first kind of thread safe code is that in your code, there may be multiple threads that are running, but there is no shared data at all. There is no shared item which they are accessing or modifying. So if that is the case, race condition is never going to happen, isn't it? For example, you can just take a look that here I have created three threads, 1, 2, and 3. And this is my worker. So let me show you what the worker does. So here, as you can see, worker has a run method which simply runs for 5 iterations and it prints hello from a certain thing, which is name. Now, if you look at this name, if I take you back to the previous class, you can easily realize it that each worker has its own copy of name. Okay. So this name variable is not shared across them. They have their own copy of name. So going by the look of it, I can say that the run method is never engaging in disturbing a variable which is shared, which is common. So if I go about running this program, I would never land into any kind of race conditions. So let's just run it and see for ourselves. Yeah, so upon running, I can see that first it was my thread B, which is the second thread that got scheduled, and hence in the first 5 iterations, we can see B, 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 and then we can see we have C's and then we have A's. Okay, these statements can also be interleaved, okay, because it can very much happen that once my thread A is running its for loop, then after maybe 3 iterations, a context switch happened to the next thread. So if you run it over and over again, you might end up seeing slightly different output also. Like here you can see that you can see a lot of B's were printed here, but not all of them, only 4 of them. And the final B was printed here. Okay, but the main item that I want you guys to understand is that in this case, there are multiple threads. The program is multi-threaded, but there is no shared data. So nothing to worry. The code is thread safe. Okay. The second kind of thread safe code is where you have multiple threads. You also have shared data, but that shared data is read-only by nature. When I say read-only, it is immutable. It cannot be changed. Okay, so every language provides you one or the other way to ensure that an item is immutable. Like you can make something final, but keep it in your mind that when you are marking a variable as final, then it is not necessary that none of its contents can be changed, because if it's a complicated object which you have marked as final, and if that object consists of an attribute which in itself is not final, then that may be changed. So this is a very important point to realize. So if you have done our low-level design course, then while learning object-oriented principles, I had talked about it there, that how you can mark a variable as completely final. In that case, you will have to recursively make every attribute of it as final. But the point that I'm trying to make over here is that if the shared data is immutable, then nothing to worry. Because immutable means the threads cannot change them. And if the threads cannot change, then there are no race conditions that are going to happen. So let's take an example. Okay. So as all of us can see here we have a public static integer, and this integer is final. It has been initialized to a value 7. Because it is final, we cannot change it. We cannot change it from 7 to anything else. So here what I have done is I have created 3 threads again, and you can see what these workers are doing this time. It's pretty much the same thing that they are doing. They are iterating for 5 times and they are printing their name, and then they are printing that lucky number, okay, which was my shared variable. Okay, so if I just go ahead and run this program, I would see that I'll never engage into any kind of race condition because the shared data over here is immutable. See, you can try to transform this. The moment you try to transform this, you will see that you are getting an error that clearly says that we cannot assign a value to a final variable. Okay, now guys, this is a very, very important thing to understand, because lot many organizations follow this kind of coding practice in their code base. So they make sure that whenever they create a particular class, they try to mark everything inside it as final. Now, the strategy behind that is to ensure thread safety, because the scalable organizations, the big organizations, cannot afford to run their code in a single threaded way. There will be multiple threads, but if they ensure that their data is always immutable, in that case, even if that data is shared across threads, there won't be any race conditions. So this is a very standard practice which is followed across organizations. So at the end, what I want you guys to understand is you have multiple threads and you have some shared data which is not changing, or in better words, which is immutable, then also race conditions will not happen. So I'll just run this program for you. And you can clearly see that everywhere it has printed the same thing, which is 7. Of course, it was not being changed. Okay, now, all the times, it might not be always possible to ensure that the threads are dealing with immutable data only. Because guys, in real world, you might face situation where there are multiple threads which are sharing a big task into small chunks of task. Like let's say there is a text file in which there are different strings, and you have 10 threads running which are basically parsing those strings and then maybe inserting those strings in a common buffer, which could be a simple list. So in this case, that list is something which is shared across all the threads, and then there can be race conditions creeping over here. Okay, now that we realize this thing, so how to take care of such scenarios where we have a common data shared across threads? By making use of thread synchronization. And the thread synchronization technique that we have just learned is about locking, acquiring lock on the critical section. Okay, so I'll show you one more piece of code over here. So I'll take you to a class called as number store. Okay, you can see that this is a number store class and it has a method called as get, which returns the number. You can see that whenever we initialize this number store, this value num is initialized to 0. Okay, and then whenever we do get, we return this number, and then there is an increment method which adds 1 to this number. You can guess why I have marked it synchronized. I have marked it synchronized so that I can get rid of the race condition that can happen here. We already remember how race conditions happen in this plus scenario, right? I've also marked it synchronized. I'll tell you in future why I have done that thing. There is one more method, but I don't want to show you that method for now. So guys, we have this main method where what I have done is I have created this number store. It's going to be a common object which will be shared across the 3 threads that I have created. You can see it's the same object that has been injected there. The 3 threads have name A, B, and C. And let's just look at what they are doing. Okay, so let's look at their run method. So in the run method, I can see that there are 5 iterations of the loop. And in these 5 iterations, what we are doing is we are printing the name of the thread. And after that, we simply want to print the value of num. So we all know that whenever we initialize number store, num is 0. So what I want is that if there are, let's say, 100 iterations across the threads, then in the first iteration, I should be printing num as 0. In the second iteration, I should be printing the num as 1. In the next iteration, it should be 2. So basically, it's the responsibility of the thread which is printing this num to change it by 1 unit so that in the next iteration, that change will be visible. This is what I want to achieve, and I want to achieve that by making use of these 2 functions for now. Okay, so if I just take you back over here, although I have used this method right now, but let me get rid of this for now. So let's say I simply use number store dot get. Okay, and after doing this thing, I'll do number store dot increment. So this is what I am doing, and yeah, we all know that get is independently synchronized, increment is also independently synchronized. So what do you think? Will it work well for us? Just pause and think. The answer is no. We have already learned about it. This is a compound action. This is very clearly a compound action. So guys, it can happen that when we have a thread that currently got the value from number store as 0, and let's say context switch happened. If the context switch happened and another thread got scheduled, then that would also get the same value which was read by the previous thread. Okay, so that is the problem. So if I run this code for you, then you can clearly see that there are problems. You can see that 0 has been printed for 3 times. But in reality, my expectation was that every thread should be printing new number, which is +1 of the previous number basically. Yeah, these numbers can be printed in random way because I don't know how the threads are going to be scheduled. They can be scheduled in random manner. But the point is that if there were 3 threads and each thread ran 5 iterations, it means 3 into 5 is 15. So I would like to see that the values from 0 to 14 are printed. And each value is printed only once. But that is not really happening here. For that, I had created a new method, and that new method is this, get and increment. This is synchronized, and this basically guards this compound action. You can see that happening here. Okay, so the change that I'll make is, instead of doing so much, I'll simply call get and increment. So now if I go ahead and run this program, you can now see that all the values from 0 to 14 are printed once. 0, 1, 2, then 3, and then you have 4, 5, 6, 7, you can see, and then 8, 9, 10, 11, 12, 13, and 14. I think all of you can see all of them, right? Okay, so that means this is the way to go ahead. Okay, these numbers are being printed randomly. I believe you understand why. It's not needed that they'll be printed in a certain sequence because let's say the first thread to be scheduled was thread B, and thread B, by the time it had concatenated these many things and created this string, which is thread B colon 0, let's say a context switch happened and now thread A got scheduled, and thread A created its own concatenated string, printed it. So it's because of scheduling that the items are being printed in this manner. But if you remember, my major concern was not to print the numbers in a sorted way. Rather, it was to ensure that each number from 0 to 15 minus 1 is printed exactly once by each thread. Okay, and that is being taken care of by making things synchronized. So this was an example where we saw that there were multiple threads, and these multiple threads had a common data. That common data was an object of number store, which contained number inside it. So basically this number was something which was under contention, which was continuously accessed by multiple threads. So we definitely needed to have check over here. We definitely needed to have some sort of synchronization over here. So guys, to sum it up again, the 3 scenarios that I have mentioned are, the first scenario is that you have a concurrent program, you have multiple threads, but you do not have any shared data. That's excellent. There won't be any race condition. Second is that you have shared data across threads, but it is immutable. So no thread can write to it. So that's also great. The third scenario is that you have some data, but now that data is shared and it is not immutable. In that case, race conditions can happen, and you have got to take care of that by proper locking. Okay. So now, whenever we say that a particular program that we have written, whether that program is thread safe or not, what that basically means is that if your program behaves as expected in single-threaded environment, then can it continue to behave like that in multi-threaded environment also? If yes, then only it is thread safe. That is the first requirement, going by which you can conclude whether your class is thread safe or not. So here I have marked all these things as synchronized. So it gives us a feel that, hey, it is going to work well. Okay. One more thing, when you talk about thread safe program, then a program that is thread safe, it should not make other programs to worry about the thread safety concerns. What I mean by that is, it's a very important point, guys. So let's say if I remove this synchronized keyword from here, if I have done something like that, in such a scenario, if at all we want to ensure some kind of thread safety, if we want to get rid of race conditions, then the client which is invoking this method will have to take care of that. So here we had a worker class. That worker class will somehow have to take care of that. And that can do it. That can probably acquire a lock somewhere and make sure that when a particular thread has invoked this method, then the other thread hasn't done so. You can see that, guys, right now at this point of time, if I run this program, you remember that I had removed that synchronized keyword, right? So if I run it right now, you can see that the output that I am receiving right now, it seems sane, it seems good, but it can just go off at any moment. It can happen that while a thread had invoked this particular method, get an increment method, during that time some sort of context switch had happened and lot of things can actually go wrong. Okay, so in that case, if worker has to ensure that there are no risk conditions, it would need to have some sort of locking over here. It might want to acquire a lock on certain object and then ensure that multiple threads are not invoking this thing again and again. So basically, writing a thread safe class means that if it works well for single threaded, it should work well for multi-threaded also. And the clients of that class should not have to worry about synchronization things. Okay, so these are some key things to be kept in mind.